So let me just let that go past. Hang on. We've been promised already there'll be some electric vertical takeoff and landing things here next year, much quieter than that type of plane. So welcome. This is a session entitled "Are Heat Pumps the Next Big Thing?" It'd be slightly underwhelming if I just say yes and drop the mic. You might think you've been slightly shortchanged, so we're not going to do that. We're going to have a proper debate about that. I would say we cannot, unfortunately, in 20-30 minutes do it justice. So our experts on the panel will be available to you afterwards over there on the grass if you've got some sort of more specific questions. But if I welcome them on board to begin with, so we've got Leah Robson from Your Energy Your Way. We have Johan Duplessis from TEPIO. Richard Lowe's from the Regulatory Assistance Project. And Matt Dodds from Herschel Infrared. Welcome. Help yourselves to some water. We're just going to do a bit of audience participation to start off with. So I guess the question is, to begin with, who has an oil boiler? Stand up if you have an oil boiler, make it clear. Okay. Who has a gas boiler? Stand up, stay up, everyone stand up. Yeah, okay, sit down then. Okay, who has a heat pump of some form already? Few? Okay, well done. Well done, because let's be honest, government haven't made that easy to this point, so well done for doing that. And okay, let's choose a timeline. In the next 5 years, who would like to have replaced their gas boiler with something else? Stand up if you agree. Okay. Right, hopefully that will give us something to talk about. Heat pumps are the next big thing. Yes, they are, but they're not the only thing. So if you've seen our home energy series recently, we talk about a number of different things. We are very excited about heat pumps, and we're going to get into that now, but there's also other things that we can talk about. So maybe, I think, Leah, can we maybe start with you, and you tell us, who you are and where you come from? Yeah.
Hi, I'm Leah. I run a company called Your Energy Your Way. We are a whole house renewables company. We try to be as technology agnostic as we can be, although we do love heat pumps. We install heat pumps, solar panels, batteries, EV chargers, all sorts of bits and pieces that are about stopping burning stuff.
Hi everyone, my name's Johan. I'm the CEO of TEPIO. So we're about 3 years old, and we're developing a different way to solve the challenge. We call it a ZEB, or a zero emission boiler. You can see one of them down there at the front. So it's basically a concept of very high density thermal storage as a means for replacing a gas boiler without all the trouble of the heat pump. So that's what we do.
Hi everyone, I'm Richard Lowe's. I work for an organisation called the Regulatory Assistance Project. We're a think tank based in the US trying to accelerate the energy transition, and I lead their work on heating.
Hi everyone, my name's Matt Dodds. I'm Director of Commercial at Herschel Infrared Heaters, and we're the UK's market leader in electric infrared heating, looking at both domestic and commercial markets.
So let's start with heat pumps first, and we'll come to some other technology as well. Richard, could you give me a little bit of a summary where we are in the UK, and what the drivers are and what's going on right now, and the importance of shifting away from fossil fuels?
Sure, so basically we've known for quite some time that a big part of a sustainable heat future has to have quite a few heat pumps in it, and that's been really the case for many, many years. And we now sort of know that they'll be a big part, so we're talking about deploying somewhere between 600 to 900,000 a year by 2028. And that's just to meet our climate change targets. So that's really the bare minimum, just to sort of scrape through. And that's a huge challenge. The issue that we've had is that for the past 10 years, the policy environment in the market hasn't been supportive for heat pumps. So fundamentally, gas is still a lot cheaper than heat pumps. And the policies which have been in place have been either underfunded or badly designed, so they really haven't made it easy for people to do heat pumps, when ultimately we need to deliver a lot very, very quickly.
Okay, and Leah, in terms of the customers you deal with, they come to you do they ask for heat pumps? Is that the kind of people you're dealing with? So people like fully charged audience members, and what's their experience of when they get them installed?
So our customers often come to us specifically for heat pumps. We try to give them as objective advice as we possibly can. There are houses that really could do with sorting their insulation out before they put in a heat pump, but we understand that people are driven by government grants and what they would like and all sorts of other customer kind of reactions and needs. So we will install heat pumps for the vast majority of our customers. They provide all their heating and hot water, and if installed well, they're a fantastic product. But one of the biggest problems that's out there in the market at the moment is the lack of really good installers. We really would like to bang the drum today about skills. This is just a kind of pet thing of mine. If any of you are sitting here who have teenage children who are wondering how on earth to save the planet, and they are really keen and at all technically minded, please encourage them to think about a career in heating, because it is such an amazing, rewarding, fantastic job, and these are the good green jobs of the future. That's what we need people to go into. Sorry, a little bit.
We would echo that. In fact, I said something similar yesterday. I think if you go into that trade, you could have a job security for the next 15, 20 years. And if you're a young person, that's not often the case right now. And also older people who might want to retrain as well. So, Richard, just sticking with heat pumps for the moment, there is the renewable heat incentive, domestic renewable heat incentive still exists. Can you tell us how much longer that goes on for, what that involves, and what's coming after that?
Yeah, so I can tell you what is supposed to be coming after it, but we don't quite know. So the domestic renewable heat incentive is a government policy that's been in place since 2014. And what it means is that if you install a heat pump, and it's via an accredited installer, so they have to go through the MCS process, you then get subsidy back from the government for 7 years following the installation of that heat pump. And it's based on the size of the house and how much energy you use. But over those 7 years, it should effectively make the cost of the heating system free. So if you can do it, you will get a free heat pump, effectively. The issue with it is that you have to fund it yourself up front. And that's not easy for everyone. And for me, I ended up putting it on a zero interest credit card, which is far from ideal. I had to put something like a 28-month term. There are some other finance packages available, but the renewable heat incentive is here at the moment and will be lasting until at least the end of March next year, so that's March 2022. So if you get your heat pump installed before then, you will be able to definitely get that subsidy, as long as it's ticked all the right boxes, which aren't too complicated to tick. Following March next year, what is supposed to be introduced is something called the Clean Heat Grant, and this is going to be slightly different, so it will be a similar amount of money overall, but you'll get the grant payment up front. Now, we don't quite know how much it will be, we don't know how many of them there will be, and if you've been watching the news, it's been discussed quite a lot. It's likely to be somewhere between £4,000 and £7,000, which would cover the vast majority. That would cover the difference between, say, a gas boiler swap and a heat pump install. So that's supposed to be coming in from April next year, but we're still waiting on the details.
We'll let you know obviously on Fully Charged when that happens. But I mean, one of the things that we often hear about with electric cars is if everyone has electric cars, won't it melt the grid? Which is obviously absolute rubbish, and has been rubbished by the National Grid on regular occasions. But the same question gets asked about heat pumps, and the reason we're so keen on them is the coefficient of performance, or COP, as you'll hear more technical people saying. I mean, can you just quickly tell us about that, Leah?
Yeah, so the coefficient of performance is an efficiency measure, really. So if you've got a really well-tuned, well-working gas boiler, for every kilowatt of energy that you put into it, you'll probably get about 0.8 kilowatts worth of heat out of it. If you put in a heat pump and it's well installed, across the year on average, you should be getting 3.5 kilowatts worth of heat for every kilowatt that you're putting in. Perhaps more. It really does depend on the fabric of your house and how well it's insulated and built. But you should not accept anything lower than that as the average performance across the year. So that's why heat pumps are the next big thing, because they are able to add renewable energy to what we're getting off the grid. It's not just a one-for-one, they're far more efficient than the equivalent gas or oil boiler.
So we've talked a bit about heat pumps, and I think we're all pretty keen, and hopefully you are as well. You can ask some more questions, particularly of Leah, I would say, and of Richard after this. But if our sort of slogan is #Stop Burning Stuff, t-shirts are available over there, then we need to look at a lot of different options, I think, and heat pumps are the ones we're really, really keen on. But when we were doing our home energy series recently on YouTube, we understood that for some people, maybe they've not got enough space for a heat pump. That's a possibility. Maybe it's quite an intrusive install. Maybe not, but are there other options for different types of properties as well? So I'm going to give Matt and Johan a bit of time to talk about the technologies that they represent. But just a quick question. In the news at the moment, heating is a subject, isn't it? It's become a big subject in the last year or so, which is great. But sometimes you hear that hydrogen is the future for heat, and I just wonder if you could tell me, everyone, in a word, whether you think hydrogen has a big role to play in heat or not. Richard, do you want to go first?
In the short term, definitely not. So we're at the trial stage, and I think 2035 is sort of moves as the earliest potential time. But everything I've seen says that using hydrogen for heat would be more expensive than using a heat pump. So for me, the short term's bad, and the long term doesn't look great either.
Anyone else?
I'd echo that. I think I'm all for being technology agnostic. Let's have market price signals that will drive the right technologies. Ultimately, you're not going to get around the efficiency of hydrogen, and it's not going to make sense to burn in people's homes. I don't think. I think there are loads of some other better uses for hydrogen, and I think it will self-defeating. It will be self-defeating.
I think it's got its place. It's a timing issue and how long it's going to take us to get there. But there's a lot more to do on it. And you've got the distinction between blue and green hydrogen as well, as I understand it. What I've read and making sure we're clear on safety and how it can work within a domestic environment.
So I think you're getting a general flavour, and Leah's not disagreeing. So I think it's quite important, I think, that we are focused on the solutions, the right ones, and not being distracted by the wrong ones. And I want to help the industry start deploying things like heat pumps. But Matt, maybe you could tell us about what you do and the type of properties it's particularly works well in.
So we work in a range of different properties. Obviously, just touching on what Leah said about insulation standards and looking at your fabric first, which is the approach that we're all recommending taking. But we're direct acting electric radiant heaters. We don't have a coefficient that heat pump will provide, but the way we're heating and what we're using in terms of the wattage that we're from each heater, we're directly heating the mass and objects of that property, which then acts as a heat store, and then you're regulating that temperature with a thermostat, so it's acting to hold the heat for longer. We're not talking about heating an air volume, which is the principal difference between us and other forms of heating. But we're looking older properties where you do need a reasonable amount of wattage, but quite often passive house and low energy home environments, and retrofit properties where people, again, from a capital perspective and a disruption perspective, don't want to look at heat pumps, and it might not be suitable for each environment. So heat pumps absolutely have got their place, but quite often we're looking at ground floor spaces with heat pumps and maybe upper floor spaces where they want less disruption, where infrared heating is going in.
So I think you can install one infrared panel or multiple. If you were going to go through like a 4-bed house or something, install a lot, how much does that cost roughly? I mean, this is
roughly on a reasonably insulated 3-bed semi-detached property, might be somewhere between £4,000 and £5,000 to supply and install.
And to put that into context, Richard, obviously heat pumps, Octopus made an announcement about where they hope to get heat pump installation costs down to. Can you remind us about that?
Well, Octopus Energy have committed to heat pump installs for next year for £5,500, which is much lower than we've seen on the market so far. So it's fantastic. They are really the market leader in terms of thinking around this, and if follow Octopus and what they're up to, because they are trying to really drive down the cost of heat pumps, which no one else has done yet because the market's so small. They actually want to get it down to the price of a gas boiler eventually, which I don't think is possible just yet. But I guess the important thing to say is that when you get your heat pump installed for the first time, that's when it's most disruptive and that's when it costs the most, because you might have to get bigger radiators or bigger pipe work and external work. And actually the difference in price between a gas boiler and a heat pump itself, the actual box, isn't that different. It's maybe a third more. So you have to think of these costs as an investment cost. But the fact that Octopus have said £5,500 is fantastic, and we'll hopefully see that coming online for next year.
Okay, that's great. And just to say, Matt and Herschel have got a stand here as well. So it's all very well him sat there, representing for infrared heaters. But if you're struggling to get your head around what that looks like, you can go and visit the Herschel stand.
D34.
D34. Equally, Octopus are here as well, showing off some really innovative technology. And that brings us to the Zero. Is it still down there? Has it moved?
I don't think someone carried it away.
Oh, okay. That brings us on to the zero emission boiler that you can see just down there, I hope, unless someone's walked away with it. Johan, I was fascinated when we first met and we found out about this technology. It seemed to overcome some hurdles that some of the other technologies have, I think. Can you tell us about your ZEB?
Yeah, absolutely. I should say, I love heat pumps. I think it's obviously a great technology. We've heard about some of the challenges with them. I suspect there'll be a few of you who have tried to get a heat pump installed and for a variety of reasons have given up or not been able to. And so what we've done with the ZEB is taken a completely different approach, and it starts really from the perspective of this energy transition from centralized generation to renewables, and the need for more and more flexibility. And actually, we said, the COP of a heat pump is great. It may not be so great in the winter when you need it the most, but that's another subject. But actually, the volatility of energy pricing during the day, and in fact the carbon intensity of the grid, is such that you can actually pretty much make up for the COP by actually having an enormous amount of flexibility. And so what we've done with this product is we've said, this ZEB has 40 kilowatt hours of thermal storage in it, which is the equivalent of about 4 300-litre water tanks. And it will do the same for you as your gas boiler, any temperature output without affecting its efficiency. But I think the big thing is that it's very easy to install. It's a plug-and-play solution. There's no need to. You should upgrade the fabric in your house if you can, but there's no need to. You don't have to change your radiators. You don't have to change your cylinder. You just plumb it in and you connect it to the electricity supply.
Are you prepared to tell us what's inside that?
Yeah. To be fair, the thermal storage technology itself is old. It's effectively a similar concept to what you have in storage heater bricks. So it's a very heavy density concrete. We've got some patented stuff around it which enables us to get the precise control that we need. And then really the cool thing, I think, is that each ZEB is communicating to our back-end IoT infrastructure, and we use machine learning to basically build a picture of how much heating you're going to use in every half hour of the day for the next 24, 48 hours, and that's continually evolving to optimize exactly when to take electricity from the grid or from your roof if you've got spare solar and that sort of thing.
And how much does that technology cost? And you'll bring out a combi version at some point as well, is that right?
We have, yes, I can't confirm exactly when, but hopefully by the end of next year we'd like to have something like that, a combi unit, which will obviously address a much larger scope of the market. At the moment this is a regular or system boiler. It's about half the price of a heat pump on average. If you take the average £10,500 for a heat pump, I appreciate Octopus are trying to bring it down, which hopefully they can, but that's roughly what it is at this stage. I should say that we've been doing trials over the last winter, and we're selling the first units in the next month or two. So.
I mean, this reminds me much of the kind of electric vehicle space 10 years ago when we were just starting, and obviously more technologies available, more interest, prices do eventually come down, but there are obviously a range of different options there between some amounts of money which are a little bit more than a boiler install potentially, but not totally out of reach. But we're not stupid, we really care about fuel poverty. On the Home Energy series we went up to Sunderland recently, we saw a large ground source array feeding SunAmps. I'm using a shoebox heat battery to feed SunAmp thermal batteries. That was a fascinating project, and in that they managed to, in 7 tower blocks, take out 364 boilers in one go, and that's a pretty incredible achievement. So there's lots of different things. Now, one of the things I've said is how do we move consumer behaviour, but actually we've got a room full of people who seem pretty open. So the question I would say is, how do we change installer behaviour? and make sure, having been badly burnt by a lack of surety before, how do we make them take this up and get more involved, Leah?
Yeah, I mean, as I said before, we definitely need more installers. And I think just to come up on something that Rich just said, we're sort of with heat pumps, we're trying to do 2 stages at once. A lot of homes in the UK run with the water that's flinging around your radiators is at about 70 or 80 degrees. Now, that's actually not a very efficient way to heat a home. If you've got a kind of really old, very badly insulated home, maybe that's okay. Maybe you need to kind of come home and absolutely blast the heating on so that you feel warm, and as soon as you go out the door, you're turning it off, because all the heat's just going out the windows and the doors and the drafts in the front door or whatever. But the majority of us don't live in homes that are that terrible, and so for those kind of homes, we need to be running our heating a lot cooler. Now, people kind of confuse that about heat pumps, because what we're trying to do with heat pumps is do those 2 things at once. We're trying to teach installers all about what we call low temperature heating, so you can comfortably heat. I live in a 1930s, very ordinary semi with cavity wall insulation, double glazing, but nothing else special. We run our heating water, even on the coldest of days, at about 45 degrees. Now that is a much more comfortable temperature to have your radiators. Believe me, you don't have that blast of heat, which I do appreciate some people like, but there is just a much more gentle, constant flow of heat. And it's not going out the walls as quickly, because of course the hotter the heat is inside compared with the temperature outside, the faster it's going to go out of the walls. So this low temperature heat transition is almost where installers need to start. You can do the same with using a TEPIO as well. You can run that, I'm assuming, on low temperature heat. That's going to be a much more efficient, carbon efficient way of heating your home. So it's kind of a 2-stage journey really for those of us in the installation business. We've got to get that message out, first of all, to every gas boiler installer and oil boiler installer in the land, that you can run heating an awful lot cooler. You might need slightly bigger pipes, you might need slightly bigger radiators, but you don't need to heat that water up to 70 or 80 degrees. So that's the first stage, and then putting heat pumps in becomes a much more straightforward process. And if you do both those things, you're going to end up with a really low carbon house.
And are the government doing anything to help the installer market at this point in time? I guess it's the incentives that really build the certainty, right?
That's it. So the only thing really driving the market is people that want to do it, and quite a few of those are in new homes. So if you're building a new house, which isn't, there's very few people, people often go for heat pumps because it's easy to put them in when you're doing that, or people who are environmentally aware, which is great. And there are lots of people doing that, and there's maybe 40 or 50,000 people a year now doing this. So the market is increasing, but the government's not helped it the scale enough. And for me, if we need to reach, we do need to meet mass market levels soon, and it needs to be as easy as possible for people to have a heat pump fitted. And companies are very good at selling things if the market's there. And I'm looking at Tesla and thinking, the market's clearly there, and they're absolutely going for it here. And that's because there's been support for electric vehicles for a long time now, and because of that, the costs have fallen and it's become normalised. And that's just not happened for heat pumps. And so the only way you can get to that scale is for the government to grow the market. And they need to just put a lot more effort into it, basically.
And it's not just government bashing. You just have to look at Europe and see how many heat pumps they're putting in. It's it exists. These markets already exist elsewhere. It's all about policy and incentivizing. And as you say, once it becomes profitable, it will then start to drive itself. But I think you keep asking for these heat pumps, maybe even write to your MPs or really apply pressure. Then the government will wake up to think that these are the best technologies to go for. Now we've got time for I think 2 or 3 questions. If people want to come to the front, we've got one gentleman there already, as keen as mustard, so I'm sure he's got a very good question. We're just waiting for this to go overhead. Do you think this is bad? We were at Silverstone before with combustion engine cars going around, so we just can't seem to completely detach ourselves from the old way of doing things, but I'm confident we will in due course. I just have a couple of rules with questions really. The first of all is, can they be quite short? And the second one is, can they end in a question mark rather than be a statement? So if you can fulfill that, otherwise, go on, okay, go ahead, sir.
We're talking about air source heat pumps, ground source heat pumps. What are the practical and legislative implications if I want to share a ground source heat pump with my one neighbour?
That's a good question. Richard is laughing, so I think he wants to take that, right?
That's a tough question for a Sunday afternoon, that's for sure. I mean, very difficult. And so the experts doing this are Kemsa, and they're here. So if you want to do this, go and talk to Kemsa, who are building ground loops. If you share land with someone, you can do whatever you want. You know, you can put a ground array across gardens. Kemsa are doing it in blocks and also in blocks, also in estates. So it is possible. There's nothing stopping you. But if you get anywhere near the highway, there is a lot of stuff stopping you, basically. It's possible, but really only if you own the land yourself, and if you're crossing boundaries, it can get incredibly difficult.
Okay, talk to Kenza is I think the answer there. Next, sir.
Great presentations, thank you very much. My question relates to maintenance of heat pump. As a new owner of a house we've had it for a year and it has a heat pump works great. But when it breaks, there doesn't seem to be anything comparable to like British Gas maintenance or anything like that.
Question for Liam.
Yeah, okay, so hopefully the installer that installed your heat pump is still around and happy to maintain it. I mean, that is definitely a question to ask any installer of a heat pump. Will you maintain and service my unit going forwards? It's just really illustrative of where we are with the market. We need to grow the installer base, and people, I've got to be honest here, people do still struggle to find people to service their units. But I think I really like the way that Dan ended the home series on YouTube and that Fully Charged it. He just said, you know, we're looking at the early adopters here, and it's a little bit like if you bought an EV kind of, you know, quite some time ago, you're going to face these kind of issues, but find the right installer that will definitely be around in 5 years and is offering a service plan would be my advice.
Thank you.
Okay, I think just might be squeezing two more if we're lucky. I think, yeah, okay. I've double thumbs, I think that means okay, yeah.
Quick one. I'm just wondering if you've addressed the issues with the air conditioning gas that are used in heat pumps and how they're, you know, like methane, a lot more bad for the environment than carbon.
Richard or Liam?
I can do it, but I always forget numbers, so I'm going to look at my fantastic engineer at the front who's going to prompt me if I get this wrong. So heat pump manufacturers are gradually working towards gases inside their units that have lower global warming potential. So Valent, for example, have just brought out a heat pump using R290, which is the number for propane, which has a global warming potential similar to CO2. I'm being prompted at 6. Okay. So some of the older units do have higher global warming potential gases inside them. Definitely make sure your unit is well maintained. They don't leak often if they're looked after properly. But there's new units coming onto the market all the time that have gases inside them that have a much lower global warming potential. So 290 is one, and 410A. No, wrong. Oh, sorry, I was doing so well.
210A, I think.
Thank you.
Sourcing the gases as well is the other issue that might see.
Well, I think we'll take that one offline because that's the kind of question that everyone else is like, get this guy off, he's too technical. But talk to Ken here in the front in a fully charged hat. He would love to talk about half an hour, I reckon. One last question.
Hi, I've got a solar PV and I'm interested in the pump depending on the fabric of my house. Is adding solar thermal to my house going to benefit having a heat pump? Is that going to take some of the work away from the heat pump and heating the water, or is it using one of those? Or because when you want your heat pump to heat your house, it's winter, there's not so much sun, it's not going to heat the water and the solar thermal so much. Is it worth doing? Is there a...
So it's not easy. My preference, if you've got roof space, would be PV plus a heat pump, because the PV can run the heat pump in the same way and at the same time that the solar thermal would be producing heat, if that makes sense. If you've got lots of roof space, you can have both. But what it means is that at some point you'd be exporting, basically, because there's a mismatch between when you install.
Wait, I've got the PV and that's happening now.
Yeah, but I would say in general, if you're a house with PV already and no heat pump, and people don't often think this way, but there's an incentive to get a heat pump because you'd be exporting less and you'd be able to self-supply a lot more of your fuel, if that makes sense.
Yeah.
So I personally think that PV and heat pumps are a better match than solar thermal and heat pumps. It depends on the size of the house and how much roof space you've got. And I should say not everyone agrees with that.
So I think, again, you can have a longer chat obviously after that. Just one more thing really to say. Thank you very much for coming, and particularly coming to this session. We also ran a session about boilers yesterday. It's quite unusual to see 1,000 people sat around wanting to talk about beyond the boilers, so that's great. When we started to do our home energy series recently, we were really looking for permission from our audience to go into this technology in more depth. So we've just done a 6-part home energy series. These are many of the stars of that series. That's on YouTube now, and I suggest you watch that. That's kind of an entry-level thing to get you to think about the whole problem and the things you need to be doing. But actually we'd like to do a lot more, but we acknowledge you can't really cover this subject quickly. It's complicated, there's a lot going on. Thankfully we have access to a lot of experts, and what I would think we'll do next year at Fully Charged Live is we'll probably have a special clinic or something like that where people can come in, book times, bring their EPCs along, talk about their houses and really get into the weeds with some installer businesses, some tech businesses to understand what is right for them, because everyone's property is very, very different, and that's why covering this technology is much, much harder in some ways than talking about cars. So that's point number one. It's join us on the mission to stop burning stuff. That's point number 2. Merchandise is available over next to the wall box stand. Point number 3 is if you could join us for the end of show today at 4:30 in the bigger Giga Theatre, nice and cool and shady in there. That would be really fantastic. We are actually giving away a Kia e-Niro for a year. So if you come along, if you want to enter that, I think you've just got time to go to the Drive Electric stand and enter that. So lots of things going on. Before I thank our guests here, I'd just like to say they'll hang around to the side here. If you have some more detailed questions, please ask them. So all that remains is to say thank you, and thank you to Matt, to Richard, to Johan, and to Leah.